Okay, everybody, let's do this last example here on Chapter 3. Here's the scenario. It says there's a 40% probability that Joey will travel to Hawaii next weekend. If he travels to Hawaii, there's a 90% chance he'll get sunburned. If he stays home, there's only a 20% chance he'll get sunburned. So you see Joey after the weekend and you notice that he's burned pretty badly. So what's the probability that he went to Hawaii then? All right, again, let's kind of think it through. There's a 40% chance he's going to Hawaii, and if he does go to Hawaii, there's a 90% chance he'll get sunburned. But if he stays at home, there's still a 20% chance he'll get sunburned. So if you see that he's sunburned, what's the likelihood that he got it in Hawaii? Let's first organize the data in a tree diagram, as we have been doing with the last two examples. So there's basically two things to kick this off. Either he goes to Hawaii or he does not. Okay, so he went to Hawaii or he stayed home. And they told us the probabilities there. They said there's a 40% chance he goes to Hawaii. So 0.40 is the probability he goes to Hawaii. The chance that he does not go to Hawaii, stay home, would be the complement. So that'd be 0.60. Now if he goes to Hawaii, he's either going to get burned or not burned. And according to the problem, there's a 90% chance he'll get sunburned if he goes to Hawaii. So if he goes to Hawaii, the chance he gets burned is 0.90. And not burned, being the complement, would be 0.10. But it also said that he could get burned by just staying at home. Even if he's home, he could still get a sunburn or not. They said it was a 20% chance he'll get burned if he stays home. Not burned being the complement, we know that would be 0.80 would be the chance that he does not get a sunburn if he stays home. Okay, here's where this is a little different than the last two we just did. The final question is a little different. It says, after the fact, we notice that he's got a sunburn. So what's the probability that he went to Hawaii? See, for all these, we are trying to find out what's the probability that he got to this ending point, right? That he missed the flight or that he tested positive. Here it's a little different. We know that he's burned. They say, look, you see him and he's burned. What's the probability that he got it here in Hawaii as opposed to being at home? So we're not looking for the end points here. We're looking for this piece. So it's calculated in a similar fashion. Just think about it this way. What are the ways he can get burned? He can go to Hawaii and get burned. He can go home and get burned. And out of those possible ways of getting burned, we want to know what's the likelihood or the probability that it happened this way, that it happened via Hawaii. So let's kind of write that down. Out of all the ways to get burned, what's the probability it happened in Hawaii? Okay, remember, probability, you could think of that as what we want, or the number of ways to pull off a success over all the possible outcomes, right? All outcomes. So what we want is we want to know, did he get it in Hawaii? I want to land in that bubble, right? So if I want to land in that avenue, the probability that I get there is Hawaii and burned. It's an and statement, so I would multiply them. Okay. So that's what I want. I want that sunburn to have come from Hawaii, meaning the probability of getting there would be 40% times 90%. Okay. Now, out of all outcomes, we're talking about all ways he could have got burned. Well, he could have got burned in Hawaii, but he could have got burned at home. So if I'm looking for this, all outcomes, all ways to get burned, out of all the ways to get burned, well, that we know how to calculate. All the ways to get burned would be just multiply down this path, multiply down this path, and add them together, just like we did in those previous two examples. So all the ways to get burned would be down the Hawaii path. You can get a burn that way. Or, meaning I add them, you can get a burn going down this path by staying at home. So 0.60 times 0.20. So again, I hope that makes a little bit of sense. I'm trying to figure out what's the probability I went down this path to get to the burn. Well, that's what I want out of two ways to get burns, this way and this way. So I've got what I want out of all possible outcomes. According to my notes, that should multiply to 0.75. Seems a little too nice, but that's what I got written down. So 75% chance that that sunburn came from Hawaii. Okay, that concludes chapter 3. I'm tired. I sat here and did these all in a row, so I hope they weren't getting too bad as they were going down the list. Like I said, I'm getting kind of brain fried myself. I'm sure you're feeling the same way. Just hang in there, guys. Use stats as a convenient distraction from everyday life right now. And again, I'll write this all up in email, but what I think is absolutely best is going to be watch these lecture notes first, then come on to our virtual class, which I'm going to give you more directions about, and you could use that time to ask me questions, look at some other examples I'm going to work out, or just work on your homework. So I would start to consider that class time more of your homework time, almost like we're flipping the class now. And what you're going to do on your own would be to watch these lecture videos and fill out the notes on your own. And again, please be pausing them and filling them out and trying the problems and all that jazz. Don't just watch them and copy what I do, because I'm going way too fast, okay? You got to make sure you're absorbing them. Okay, I'm signing off. Last video for chapter 3, and I'll talk to you soon.